One of the most intriguing questions we've all wondered about when we were kids is whether we can travel into the future or go back in time using some sort of time machine.
What NASA isn't telling you about time travel. New findings confirm it's possible. NASA has secretly uncovered evidence that time travel is possible and may already be within our reach. Recent breakthroughs confirm that bending the fabric of time is a scientific reality, no longer confined to the realm of fiction.
We can easily travel forward in time, and we've known how to do that since 1905. Einstein's special theory of relativity lays out the whole recipe of how you can move into the future.
And while NASA remains tight-lipped, startling new findings are beginning to surface, confirming what was once thought impossible. The quantum time loop. NASA has been quietly investigating one of the most mind-bending concepts in modern physics, quantum time loops. This breakthrough has the potential to fundamentally change how we understand time and could pave the way for practical time travel in the not-so-distant future. At the core of this revolutionary idea is quantum entanglement, where particles, even when separated by vast distances, remain interconnected. Altering one particle immediately affects the other, regardless of space. But here's where things get even more fascinating. NASA researchers have proposed that these particles might not just communicate through space, but also through time. In simpler terms, it's possible that information could flow backward, allowing particles to know about changes that haven't even happened yet in our timeline. This leads to a groundbreaking possibility: the future influencing the past. If quantum time loops are real, they would allow for information to travel across different points in time, potentially enabling time travel on a micro level, like sending messages to the past. Imagine sending a quantum signal back to inform a past version of yourself about a crucial decision. As NASA continues its exploration, the question isn't just whether we can alter the past, but also what the consequences of such changes might be. Could we create entirely new timelines, leading to alternate realities? What ethical dilemmas would arise from being able to interact with the past? This technology could one day allow us to traverse time as we currently explore space, opening up countless possibilities for humanity. The potential applications are limitless. Imagine a future where quantum computers using quantum time loops can process information not only faster than traditional computers, but also learn from both the past and the future. These advanced systems could revolutionize industries from medicine to engineering, helping us solve problems before they even arise. While this may seem like science fiction, the research is real. NASA's experiments with photons, the particles of light, may provide the first glimpse into a future where time isn't just a straight line, but something far more complex and flexible. By delving into the intricacies of quantum physics, NASA is pushing the boundaries of our understanding of reality itself. If you're intrigued by these groundbreaking findings and want to stay updated on NASA's latest discoveries in time travel and quantum physics, be sure to subscribe to our channel. Don't miss out on our upcoming videos that delve deeper into these mind-blowing concepts. Join us on this incredible journey through time and space, manipulating time. The quest for practical time travel has fascinated scientists and dreamers alike for centuries, and recent advancements in physics have brought this age-old idea closer to reality than ever before. Parallel to their work on quantum mechanics, NASA's most promising area of research involves gravitational waves, ripples in space-time, caused by massive cosmic events like black hole collisions. Since gravitational waves were first detected in 2015, they have offered NASA a new way to investigate time itself. Gravitational waves are ripples in space-time, caused by massive celestial events such as the collision of black holes. These waves have been invaluable in understanding the fabric of the universe, but they also hold a hidden potential that NASA is beginning to tap into: time manipulation. The core idea is both simple and profound. Gravitational waves distort space-time, bending the flow of time as they pass through it. If scientists can manipulate these waves in a controlled manner, they might be able to influence the passage of time. Imagine being able to slow down or speed up time, or even reverse it by controlling these cosmic ripples. NASA has been conducting groundbreaking experiments using high-energy simulations and particle accelerators, attempting to replicate these distortions on a smaller scale. Early results have been astonishing. Researchers have been able able to create time ripples, tiny space-time disturbances that allow for the transmission of information through time. In some of these experiments, atomic particles were successfully sent a fraction of a second back in time. While this might seem minuscule, the implications are enormous. These experiments could be the first steps toward practical time travel. If refined and scaled, this technology could potentially move larger systems or even humans through time. NASA's work with gravitational waves is closely tied to its collaboration with the European Space Agency on a mission called LISA, Laser Interferometer Space Antenna. This future space-based observatory will detect gravitational waves that are much longer than those picked up by ground-based detectors like LIGO. Just imagine the possibilities: being able to travel back to witness historical events firsthand or solve unsolved mysteries by visiting the past. As we continue to uncover the secrets of gravitational waves, we may find ourselves not just exploring distant planets, but also peering into the past and future. The combination of quantum mechanics and gravitational wave research paints a thrilling picture of what lies ahead for humanity. Time dilation. Just as gravitational waves distort space-time on a cosmic scale, time dilation reveals how speed and gravity can bend time itself, bringing us one step closer to understanding the mechanics of time travel. Time dilation, a cornerstone of Einstein's theory of relativity, demonstrates that time is not a fixed entity, but a variable influenced by speed and gravity. When an object approaches the speed of light, time for that object slows down relative to a stationary observer. This means that if you were to travel in a spaceship at near light speed, you could age significantly less than those remaining on Earth. This concept was vividly illustrated through experiments with atomic clocks, where high-speed jets revealed measurable time differences, confirming that time can stretch and compress under different conditions. In the sphere of time travel, time dilation opens incredible opportunities. If only we could tap into these effects, then we could actually get to move around in time in the way that most science fiction movies and books have depicted. The consequences include possible future trips, during which time the traveler may slow down to a crawl while the rest of the universe moves on. This opens an interesting view of theoretical time travel, and the research claims that it is possible to travel into the future given the necessary speed. NASA is still focusing on the effects of time dilation in space travel and maybe even in time travel. Though minuscule, the time is different between the astronauts traveling at high speeds at the International Space Station (ISS) and people on Earth. This difference, of course, is somewhat small, but compounds over the duration of long missions. NASA research is also focused on the potential for using these effects to develop methods of advanced propulsion, for example, to reduce the effects of aging during long missions to Mars and beyond. The concept of time dilation is one of the cornerstones of modern physics, and through the work of NASA, it is brought to life, transforming science fiction into reality and bringing us a little closer to the dream of practical time travel. Wormholes. While time dilation offers a glimpse into how time can stretch and slow down at extreme speeds, wormholes present an even more mind-bending possibility: the ability to bypass time and space altogether through shortcuts in the fabric of the universe. NASA's research into wormholes opens up exciting possibilities for time travel, suggesting that we might one day move not just through space, but also through time. Wormholes are theoretical shortcuts in the fabric of space-time, connecting two distant points in the universe. The idea was popularized by physicist Kip Thorne, who proposed that if we could stabilize and use a wormhole, it might allow us to travel to the past or the future. The mechanics of a wormhole are mind-boggling yet fascinating. Imagine one end of a wormhole is moving close to the speed of light, or is near a massive object like a black hole. This would cause time to slow down at that end compared to the other end. So, if you entered the wormhole, you could come out at a different time than when you entered. It's like stepping back into history. However, the process of constructing a wormhole and stabilizing it is a monumental process. One major obstacle is the requirement for negative energy, energy that opposes gravity and maintains the stability of the wormhole. Theoretical predictions on the amount of negative energy needed can rise to a level beyond that which a star generates. Without this special energy, any wormhole created would likely close up before anyone could use it. Wormholes also bring up tricky questions about time travel and its effects on history. For example, if someone traveled back in time and changed something important, it could create problems, like preventing their own existence. Physicist Stephen Hawking suggested that the universe might have rules in place to stop these kinds of paradoxes from happening. Despite these challenges, NASA's ongoing research into gravitational waves and quantum mechanics keeps hope alive for future breakthroughs. As scientists learn more about these concepts, we may be getting closer to understanding how to manipulate space-time. The dream of traveling through time using wormholes might not be as impossible as it seems. It could become a reality one day. With each discovery, we move closer to unlocking the secrets of time travel and expanding our ability to explore not just space, but also time itself. Mars time anomalies. NASA's exploration of Mars has revealed fascinating time anomalies that may hold clues to understanding time travel. Perhaps one of the most interesting phenomena is that time on Mars is different from time on Earth. A Martian day, or sol, is a day and night cycle that is 24 hours, 39 minutes, and 35 seconds long, which is longer than an Earth day. This difference implies that there is a need to adjust the time to suit Martian time, especially for the Mars Science Laboratory and Curiosity rover. To further complicate matters, there is the issue of the eccentricity of Mars's orbit around the Sun. When thinking about time anomalies, Mars orbits the Sun in an ellipse that is slightly larger than Earth's orbit and takes more time to travel around the Sun than it does the Earth. This leads to an equation of time, EOT, that can be particularly large, ranging from 51.1 minutes to plus 139.9 minutes, depending on the Martian longitude. These oscillations make solar time on Mars differ from clock time, which complicates work for the mission's planners, who need accurate timing for experiments and navigation. NASA's rovers and orbiters, like the Curiosity rover and the Mars Reconnaissance Orbiter, have gathered data showing how gravity on Mars may subtly alter the flow of time, similar to how Einstein's theory of general relativity predicts time dilation near large gravitational objects. While these effects are much weaker than those near black holes or stars, they are still measurable and could have implications for future human missions to Mars, especially regarding communication and navigation. Surprisingly, some scholars believe that the knowledge of such temporal distortions may eventually provide a basis for time travel inventions. We may see how to control or bend time more effectively if we can understand how it works under various conditions of gravity. As NASA continues to explore these anomalies, they may be uncovering secrets not just about Mars, but also about the nature of time itself. The findings could hint at a future where manipulating time is not just a dream, but a tangible possibility, paving the way for revolutionary advancements in space exploration and perhaps even time travel itself. The role of black holes in time travel. NASA's exploration of black holes has sparked fascinating discussions about time travel, primarily due to their ability to warp space and time. But what exactly is a black hole? In simple terms, a black hole is a region in space where gravity is so strong that nothing, not even light, can escape its pull. This incredible force occurs when a massive star runs out of fuel and collapses under its gravity, condensing its mass into a tiny area. The boundary around a black hole is called the event horizon, which marks the point of no return. According to Einstein's theory of relativity, the presence of a massive object like a black hole can change how time flows. For instance, if an astronaut stays close to a black hole when he comes back to the Earth, many years would have been spent. This idea was best demonstrated in the Hollywood movie Interstellar, where the characters spent different amounts of time when close to a black hole. Black hole as a method of time travel is based on the ability of black holes to form closed time-like curves. These curves could, in theory, enable travel in the past or backward through time. But there are significant obstacles in its way. To get into a black hole, a person has to pass the event horizon, through which nothing can exit. Inside, the gravitational forces are so strong that they would probably collapse anything that came within their reach, and therefore cannot escape. Interestingly, some theories indicate that the Kerr black holes, which rotate, can open different possibilities for time travel. Under some circumstances, these spinning black holes could produce corridors called naked singularities that may let you travel through time without becoming locked in. These concepts are fascinating. However, the practical application of black holes in time travel is still just a theory. There is no technology yet that can allow a spaceship to come close to a black hole or use its properties to manipulate time. If we could get to one, the risks would be immeasurable. Black holes are fascinating and offer prospects to comprehend time and at least consider time traveling. NASA's ongoing research into these cosmic wonders helps us learn more about the nature of time itself and may eventually bring us closer to the idea of time travel. However, for now, these concepts remain fascinating theories rather than practical realities. As scientists continue to study black holes, we may uncover new insights that could reshape our understanding of space and time in the future. Quantum entanglement and time communication. NASA is making significant strides in the field of quantum entanglement, particularly through its upcoming experiment called the Space Entanglement and Annealing Quantum Experiment, SEAC, set to launch soon. This mission aims to test whether two entangled photons can remain linked while in space, which could revolutionize how we communicate and process information. At its core, quantum entanglement involves pairs of particles that are interconnected in such a way that changing the state of one particle instantly affects the other, regardless of the distance separating them. This unique property has the potential to enable secure communication and enhance the capabilities of quantum computers. For instance, if two quantum computers could communicate through entangled particles, they could work together as a more powerful system, effectively combining their processing abilities. The SEAC experiment will be conducted on the International Space Station, ISS, and will utilize a new technology based on integrated optics. Unlike previous experiments that relied on bulk optics to create entangled photons, SEAC will use a waveguide, a microscopic structure that directs photons with minimal loss of their quantum state. This innovation makes the system smaller, more robust, and more efficient than earlier methods. One of the exciting aspects of SEAC is its potential to create a global quantum network. By demonstrating how orbiting nodes can connect with quantum transmitters and receivers over long distances, NASA hopes to lay the groundwork for future quantum communications that could link devices anywhere on Earth or even in space. This could lead to advancements in quantum cloud computing, where data can be exchanged and processed regardless of location. Moreover, SEAC will also test a technique designed to help these space-based nodes self-heal from radiation damage, a common challenge for delicate instruments operating outside Earth's protective atmosphere. By using a bright laser to repair defects caused by radiation, the experiment aims to prolong the life and effectiveness of quantum systems in space. As NASA continues to explore these groundbreaking concepts, the implications for time travel and our understanding of physics could be profound. The ability to manipulate quantum states and maintain entanglement over vast distances may one day unlock new avenues for exploring not just space, but also time itself. Keep an eye on NASA's developments in quantum entanglement. They may be paving the way for future technologies that could change our world, measuring time at the quantum level. NASA's advanced study of optical atomic clocks is changing the way time is measured, which might even have an impact on time travel. This new generation of clocks operate through atom counting from elements like strontium or ytterbium at a much higher oscillation than the current atomic microwave signal. The optical atomic clock resonance frequencies are nearly 429 trillion cycles per second, making the clocks very accurate. Because the atoms can be cooled and trapped with lasers, another another laser can excite the atoms and give a tick, so the uncertainty is less than 1 second in billions of years. Recent development has taken this technology to another level. Researchers are studying how the phenomenon in which pairs of particles influence each other in a way that a change in one determines a change in the other can improve the efficiency of optical clocks. This might open new approaches to managing time at its most basic and provide hints to the possibilities of personal time control, a theme of both theoretical science and science fiction. For now, traveling in time may still be just the stuff of movies and science fiction, but the efforts toward developing optical atomic clocks are of tremendous application. These clocks could enhance GPS and other systems, making navigation hundreds of times better and testing Einstein's theories of gravity and the space-time continuum. Such telescopes may also give a new perspective on other enigmatic phenomena, such as dark energy and the characteristics of gravitational waves. The future of optical atomic clocks is very bright, not only in terms of the miniaturization of the technology behind these devices, but also in terms of a better understanding of the nature of time itself. We may be on the cusp of some breakthroughs that will revolutionize time and space, or at least bring us closer to realizing the dream of time travel. Cosmic strings. Cosmic strings are hypothetical, one-dimensional defects that may have formed in the early universe, and knowledge of them could revolutionize our vision of time and space-time control. Perhaps these incredibly thin but massively dense objects formed during phase transitions soon after the Big Bang and caused new forms of structure in space-time. Cosmic strings were initially introduced by physicist Tom Kibble in the 1970s and are currently a topic of intense research in both cosmology and string theory, with fascinating implications in time travel and the infancy of the universe. Another fascinating aspect of cosmic strings is that they can warp space around them. This distortion could theoretically create closed, time-like curves, or in other words, a path that an object could follow that would allow it to return to its past, which completely contradicts our traditional understanding of cause and effect. The strings could also exert gravitational forces that could be seen as gravitational lensing, warping of light around the strings, or distortions in the cosmic microwave background. These phenomena might give hints for the existence of these things and would have dramatic consequences in the time travel theory. NASA, apart from considering the cosmic strings as time manipulators, NASA sees them as the key to understanding the large-scale structure of the universe. Cosmic strings, if observed, can be the final nail in the coffin for string theory, the notion that every particle is a string that vibrates. Finding cosmic strings may help astronomers unravel the secrets of the universe's birth and even check the theories about time travel. Scientists are already employing devices such as LIGO and Virgo to look for gravitational waves in space-time that can be generated by cosmic strings. These waves could contain details on how cosmic strings engage with matter and light, and that is evidence that they exist. As we refine our ability to observe gravitational anomalies, we may soon be able to confirm the presence of cosmic strings and begin to understand how they could manipulate time. Cosmic strings could revolutionize our understanding of time, gravity, and the universe. By warping space-time, they might unlock the door to time travel and reveal secrets about our cosmos that were once thought to be impossible. Alternate time travel theories. Exploring time travel theories beyond NASA's current research reveals two fascinating concepts: the Tipler cylinder and the donut-shaped vacuum models. The Tipler cylinder, which was developed by the physicist Frank J. Tipler in 1974, indicates that a massive cylinder with infinite length and rotating near light speed can lead to the formation of closed, time-like curves in space-time. This, of course, implies that if an object were to orbit the cylinder in a certain way, perhaps the object could travel back in time. Such corridors were created because an immense gravitational field would be generated by the cylinder, deforming space around it. However, there are certain difficulties in it. For example, the necessary is an infinite cylinder, and the conditions for maintaining such rotation are very severe. Another theory that many find interesting is donut-shaped vacuum models, which insist that altering space-time geometry is a way of traveling in time. In this model, space-time is a toroidal structure that provides pathways in space-time that could mean temporal travel. If there was a way to form a stable vacuum state with specific parameters, it would be possible to reach points in time without touching on the paradoxes that are normally associated with time travel. In the core of this donut-shaped vacuum, according to theoretical physicist Amos Ory, focused gravitational fields could create closed loops of time. The Tipler cylinder and other donut-like vacuum models serve as better solutions to NASA's concentration on cosmic strings and quantum mechanics. While NASA explores empirical research methods, probing time through gravitational waves and quantum entanglement, these theories suggest thus exploring the nature of time more proactively. If they are true, they can help to alter the conventional approach to the concept of causality and offer fresh possibilities for genuine time travel. These concepts are still largely hypothetical, but they advance the envelope of what is currently conceivable in the field of physics. While NASA's research continues to advance our understanding of time and space, alternate theories like the Tipler cylinder and donut-shaped vacuum models offer intriguing possibilities for how we might one day achieve time travel. As scientists explore these ideas further, we may uncover new insights into the intricate nature of the universe and our place within it. As we teeter on the edge of a groundbreaking revolution in our understanding of time travel, NASA's cutting-edge research is tearing down the walls between science fiction and reality. The potential to manipulate time is no longer just a dream. It's an emerging possibility that could reshape our entire understanding of the universe. Don't miss out on this thrilling journey into the unknown. Hit that subscribe button and join our community as we dive deeper into the astonishing discoveries and what they mean for our future. Share your thoughts in the comments, and let's explore the incredible world of time travel together.